Okay. Alrighty. So problem types, momentum, and linear collisions. So we're going to start with a linear collision, one ball at rest. So a same stuff. A 4 kilogram ball moving at 4 meters per second east strikes another mass 2 kilograms at rest. If the final velocity of the 4 kilogram ball is 2, find the final velocity of the smaller mass. Okay, so I'm going to draw a picture here. This one is 4, and I'm going to draw it a different color just to identify a little bit better. 2. And this guy is moving at 4 meters per second, and this guy is at rest, right? That's the initial?
PI equals PF.
Right. I'm going to draw over here, I'm going to say equals, and then the final, if the final velocity of the 4 kilogram ball is 2 meters per second east, so this one here ends up going, oh, I should draw it the same size, I guess. That's what we have to find, right?
So why is the bigger one still moving? Yeah, so
Again, that's a good question. Perfectly elastic only happens really at subatomic levels.
Elastic is when the pool ball, right?
Yeah.
It stops.
Inelastic is when there's no bounce and they stick together, right? Elastic is when there's a bounce, but generally that doesn't happen in real life. It's not all transferred.
But inelastics also don't have enough.
Well, that's true, right?
There's really no perfect.
Yeah. Alrighty, so again, PI is equal to PF, which stands for initial momentum is equal to final momentum, right? So we've got, now I could write, sometimes I write like M1 V1 plus M2 V2 is equal to M1 V1 plus M2 V2, and these guys are prime. What does that little prime thing mean? After collision, right? If you want to write that out, that's fine. If you want to just go to the next step and just write 4 times 4 plus, this one would be 0, right? Is equal to 4 times 2 plus 2 times V2 prime. Like the math is never hard, the arithmetic. What's hard is the setup in these, right? So here I've got 16, here I've got 8 plus 2 V2 prime.
So 8 equals 2 V2 prime.
Yeah. 8 equals 2 V2 prime. V2 prime then is equal to 4 meters per second.
It all got transferred over.
Well, yeah.
No, but it's half that.
The total is the same, though, right? Like, I got 16 here, right? I got 2 times 4 is 8. I got 16 on the right. Momentum is conserved.
Yeah.
Make sense? All right, here's number 2. This time we've got, they're both moving in the same direction. So a 6 kilogram ball traveling at 4 meters per second east overtakes a 2 kilogram ball moving at 3. If the final velocity of the 6 kilogram ball is 2,
What is does your appendix have a purpose? Because I thought like no one knows why it's there.
There's a theory that used to be used when we were like cavemen.
yeah, something
We
like
used to
that.
see a lot of planets and moving.
Like, we don't need any more, do we? Like that is just like a useless thing.
Now they're trying to say that we need it for some other stuff. You have to look.
Okay, so PI is equal to PF.
Well, could you
M1 V1 plus M2 V2 is equal
Could
to
you-
M1 V1 prime plus M2 V2 prime. I'm listening.
could you talk?
All right, well, here we go. So M1 V1 is going to be 6 times 4. M2 V2 is going to be 2 times 3. M1 V1 over here is going to be 6 times 2, and here it's going to be 2 times V2 prime. Like, what's the difference between this one and the other one? Like, there is nothing. The only difference here is that
Different things.
instead of a 0 there, I got 6. Ooh. Right? 24 plus 6 is equal to 12 plus 2 V2 prime. Is that right? 9 meters per second?
Do you need an arrow at the end? Like a east arrow?
I don't, because the positive indicates that it's to the right. But good
VO, what
question.
is that VO then?
That's a V2 that just didn't get drawn very well. All right, last one. A 1 kilogram ball with a 3 meter per second east strikes a 6 kilogram ball moving west. Blah, 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 blah. And you know what? Mackenzie's right. It's exact same except what? One of them's going to be negative. PI is PF. M1B1 plus M2V2 is equal to M1B1 prime plus M2V2 prime.
We need a picture.
You don't need a
We
picture,
need a picture.
Draw it then.
Michael.
You can draw it.
1 2 seconds.
5 meters per second advance.
Strikes a 6 ball. Moving west.
Bet you can't run 5 meters per second.
Which the final velocity.
15. You're not passing it wrong. Actually, 5 meters per second is probably the closest or something like that. That's
Okay, so M1V1 here is going to be 3 times 1. M2V2 is simply going to be 6 times minus 5. After the final velocity of the 1 kilogram ball is 9 west, so that's going to be 1 kilogram. Oh, hang on here. I got 3 times 1. Oh, this should be 1 times 3, right? I got them backwards. This should be.
The other one's 1 times back of 9. Yeah, you good.
Right? Can I plug them in the right spots?
6.
3 plus minus 30 is equal to minus 9 plus 6 V2 prime.
going 3 meters per second. I think.
Stop spoiling.
That's just the math.
Yeah, spoiler alert.
You spoiling, dude.
It's 9, that's going to be
Oh, I think I did it wrong.
Minus 18.
it's going to have to be.
Why is it minus 18?
Is that right? I think so. So in other words, they both end up going west.
That makes sense.
I think-
That's a big ball.
Yeah, you're right. Way more momentum over here on the right, right? Way more. We got like 30. 30 to the right.
It wasn't that bad. Let's pack it up. Maybe not.
I still have an hour.